My name is Ricky Wynn. I'm a Senior Applications Engineer with Hawkridge Systems, and today we'll be going over assembly techniques. So just really quickly, a little bit about Hawkridge Systems. I'm sure most of you guys are customers, but if you're, some are not, or just a little quick reminder, we're an engineering manufacturing 3D solutions. We have 18 offices and training centers in Canada and the U.S. as well. Over 180 people and 80 certified engineers, support engineers, application engineers as well. Founded in 1996 in the Bay Area, serving over 12,000 customers, right, from all different fields. And we're the #1 reseller for 5 out of the past 8 years. And in addition to that, we also do 3D printers as well. We're selling professional and production 3D printers, partner with 3D Systems, as well as a reseller for CamWorks. So if you guys have an interest in that, feel free to reach out to us. So for today's night school, I want to go over assembly techniques. Okay, you can see here from the agenda, we're going to talk about top-down design, mating techniques actually, toolbox components, large assembly performance, and file references are actually going to be covered more tomorrow. Okay, so this is 2 sessions. It's 1 hour today, and then 1 hour tomorrow. And we're going to be covering over top-down design, even though it's only the first part. It's a large portion of what we cover for the overall night school. Right? We're going to talk about in-context design, managing external references, kind of how to remove them if you need to, what they are, and then also master modeling. Okay, so that's today's agenda. So, usually in a live event, I kind of get everyone's participation in terms of whether, what I ask questions and making sure that they understand this. Obviously, can't really have you guys doing that. You guys are not going to be at your computer. But, kind of as we're going through, just think, hey, I know this or don't know this. Take notes of the shortcuts, some of the options we're going to go over, and then just make sure you get a lot of value out of it. So for the beginning, what we want to talk about is bottom-up versus top-down design. Okay. So, the first one we talk about is usually most people create their parts kind of like Lego pieces, right? And then afterwards, what they do is they assemble it. And these parts are referenced to each other using mates. And this is bottom-up design, okay? And top-down design is really the reverse. You have your assembly already. You kind of have like a layout, or you have it built together, maybe by bottom-up design. And what you'll do is you will then have parts that are referenced that assembly. Okay, so that is top-down design. I have explained the pros and cons of bottom-up and top-down design. Okay, so actually that's the next slide. So that's a great precursor to what we're going to cover. And I just want to mention that you can use this interchangeably, right? It's not just one. You can do bottom-up and then decide afterwards, hey, I need a part that references the assembly, then you can do top-down. So you can mix and match between the two, as long as you have a plan for it. So we talk about top-down in-context design. And the question was, okay, what are the advantages for each? So here for top-down design, it allows you to capture the design intent, right? And also parts will parametrically and automatically update with the assembly. So for instance, you have a one-of-a-kind component that is specific to this assembly, you want to resize to that one, right? Based off of how other components are changing and moving. The disadvantage is that unexpected changes can occur, right? So that must mean that those external references. So where you would want to use this is more of a one-of-a-kind custom components specific to a particular assembly, right? So that's where you would want to use most likely your top-down design is, say we're going to do a pump guard. That pump guard is not going to be used elsewhere in another assembly. It's going to be specific to this one. So you can see here I put a quote, with great power comes great responsibility. It's very powerful, but at the same time you have to also learn how to manage it. To kind of follow up on that question, bottom up, it's going to be, you have one another. You can use those parts interchangeably in another assembly, and you won't have them automatically update. They're not referencing that other assembly, right? So they can be used in multiple different assemblies. That would be the main difference. You have what we call external references. With bottom up, you generally don't, unless you make some in-context changes. but with top-down you do, that's going to be specific to that assembly, the one of a kind. Now we have virtual, and that's what we're going to do first of all when we pop into our assembly. So let's go ahead and do that. And we're going to be taking a look at this Resman Bolter 77D. And you can see here it's about 5,000 plus components. I'll show you guys later on how I determined that number. I didn't have to kind of go through every single component and count it. And what I want to focus on specifically is a pump guard, and it's going to be this guy here, okay? And what I want to do is I want to scroll up and then find that assembly that I want to work with, which is this one. I'm going to open this up. And what I want to do is there's actually a dimension in here that's very, very important, okay? And I have it listed here as a support distance. And what I want to do before I change this, I want to take a look at it. You can see here the holes line up with this other side. Okay? So you can see that the holes line up. And, you know, that's great. That's going to be able to put my nuts and my bolts in and everything like that and have it go in correctly. And then also on the other side as well, over here. Okay, you can see that they line up. And these are going to be hole wizard holes, right? Now what I'm going to find is this was created in bottom up. It was just inserted in and it was mated together. But I'm going to modify this to be 700. And what I'm going to find is once I rebuild this, is that the holes are no longer going to maintain. I have this one still lined up, but then over here, these holes no longer line up. Okay, so what I can do is I exchange this, right? I can edit this part and then make sure that those holes are being driven by the holes on this plate, on this part. But since this is a simple part, I'm going to go ahead and just recreate it. Okay, so I'll select it. I'm going to go ahead and right-click and then delete. And then now I'm going to go ahead and create a part. Okay, so in this case, I'm going to create what we call a virtual component. Okay, and this is done in context, so this is the beginning of top-down design. I'm going to pull the drop-down menu under your Insert Components, and I'm going to go to New Part. Okay, notice not too much happens. Doesn't look like it happened at all, but there's a green check mark on my mouse. And on the lower left-hand corner, it says select the face or plane on which to position the new part. So what I have to do is select the plane that I want to make basically my front plane for my new part. Once I click on, for example, this one, notice what happens. Up top, my command manager changes from a assembly to now a part. You'll see features, sketch, surfaces, sheet metal, weldments. Those will only be available inside of a part. If I look on the left-hand side, if I expand out my feature tree, there's a specific component that's in blue. That's the part that I'm editing. Okay, you can see here it says Part 1. You'll also notice the subtle difference that this is displayed in brackets. The brackets is indicating this is a virtual component. If I were to right-click this, I can also rename this part. So it allows me to click on Rename, and I can type in, for example, pump guard. You wouldn't be able to do that if this was a quote-unquote real part. Okay, so it's a virtual component, meaning that this component lies only inside this assembly. I just designated that this is a one-of-a-kind component. So if I looked anywhere on my machine for this external file, you wouldn't be able to find it. Okay, so this is a virtual component. Now if I pop back over, and what I'm going to do is now sketch out the profile for my pump guard, right? I'm going to exit out my sketch, and I'm going to start a sketch on my top plane. This is the top plane of the pump guard. And it's just going to be a couple lines. and another line over here. And, you know, just to make sure, I'm going to be using this interchangeably. Sometimes I just want to make sure you guys catch it. The mouse gestures, right? If you guys don't know how to customize this, I can show you guys, if you guys have questions about it, how to activate it. It's useful for time-saving tips. For example, if I'm trying to create a line, I can right-click and go over here, create a line, and then go up. Right-click and go up, and I can immediately dimension this without having to move my mouse too much around onto the command manager. Okay, it's the same exact process if I did it manually, but then I find with the mouse gestures a little bit faster. Shortcut. I'm going to go ahead and delete that. And what I want to do also is I'm going to add some relations to this. I'm going to select this point, and there's also a point over here that I want to select near my assembly. So without having to zoom in, there's also another shortcut that we use as well. It's called the magnifying glass. If you click on the G key, so G key on your keyboard, you can actually activate this magnifying glass in to exactly what I want to capture. In this case, I just want to capture this vertex. Okay. Click escape to get out of my magnifying glass. Notice how it stays selected. And then I can select this point, and I can go ahead and make them coincident. So the G key is going to allow you to zoom in when you, say for example, when you're in a situation where you can't find something, like for example, I can't zoom into that edge, I might lose where I'm at. I click on the G key, zoom in, grab whatever I need to, and grab the other entity, and then go ahead and make that coincident as needed. Okay? This is going to be 50. I have my point and my point here. That's going to be 150. The value of this line will be 200. And lastly, I have an angle between these two lines to be 45 degrees. I have a fully defined sketch. So I'm going to go ahead and go to my sheet metal. There's going to be a base flange. I'm going to have this going up to that same exact vertex. Click escape to get out of the magnifying glass. We're going to use a steel, and we're going to be using 3 gauge for this one. I'm also going to make sure that I have my material going to the right direction. Okay, you can see how I do have it going to the correct direction. If I have it going to the other way, that's not the one I want. So I'll go ahead and reverse the direction, make sure it's going out. Then go ahead and press OK. Then you'll see we have the beginning of our pump card. Okay, so even though this is a virtual component, I can still right-click and then open it. Right. Once again, I won't be able to find it anywhere in my system, but if I, wanted to make some cuts on here just by itself, I can go ahead and do that. I can go ahead and add in some dimensions. This will be 125. This will be 300. If I want to add in a fillet, I can do that. I'll go ahead and be 80. And lastly, a dimension from the bottom to the line, that'll be 150. I'll go ahead and do an extruded cut. I'll link it to its thickness, and then press it. If I pop back over to my assembly, you can see that it's still transferred over there as well. Okay, go and update my assembly, and then it still looks good. A couple more things. If I wanted to add an edge flange, I can go ahead and do that. That's where my holes are going to be. Set that to be 80. Then next, what I want to do are the holes. Now, I'm going to do this one first. I'm going to take just a regular sketch entity, do those extruded cuts, and on the other side, I'm going to go ahead and do the whole wizard holes. Okay. So first thing first is I'm going to go ahead and start a sketch on this face. I'm going to rotate, and what I want to do is I want to grab the diameters of these holes, position of them. Okay. you can see the ones that I have highlighted here. I want to go ahead and pop that onto the sketch that I'm on and do the extruded cut. So wherever the position is, it's going to move to it, and also the size, the diameter will also resize as well. So if you guys have done an Essentials class before or just used it, the easiest way to get those sketches onto that sketch plane is to do what we call convert entities. Okay? So you click on convert entities, it converts the model edges you selected onto the sketch. If you forget where it is, if you pull the drop-down menu and go to Commands, you can actually search for convert entities. Right? Say you know the name, I had mentioned it before, but you don't know where it is. You can click on this to activate it, or you can press the Show Command Location. This will allow you to, it actually has a little arrow, red arrow, to show you exactly where the location of that feature is. So I click on Convert Entities, and you'll see here, it's created fully defined geometry onto that sketch that I'm on. That will allow me now to go to an extruded cut, run through all, and press OK. So what's happened is I've created a sketch on that face, but I've converted the edges onto that one and done an extruded cut, so the positions, and they will always line up. So over here, I'm not going to do an extruded cut. I'm going to do what we call, that allows me to use predefined cross sections. So in this case, I know that I'm looking for M12 holes. So I'll go to, once we define the type, we can go into the Position tab, click on the face, and then now I have my little asterisk tool to allow me to place exactly where I want those holes to be. So I'm just going to go to the inside of this. And one little trick that I use is I go ahead and move my cursor over the circumference of the circle, the edge. The plus pops up, indicating where the center of that hole is. And then go ahead and left click and place the center there. Place the asterisk there. And now move over here. I can go ahead and see the plus pop up, and I'll just left click. You can also do axes. You can also add in a concentric relation as well. Okay. Once we're done, we'll go ahead and press OK. And we'll make sure that it's lined up correctly. And it looks good. Some other simple modifications is if I want the same color to be the same color here, right? If you've ever tried a shortcut you can do is you can right click on it, the color you want to copy, and go to Copy Appearance. You'll then right click on the part you want to paste it to and go to Paste. This little menu will pop up where you can choose if you want it to apply to the face, the feature, the body, the part. And I'll want to go ahead and propagate it down to the part. You can see it copies over that appearance. I'll go ahead and go out of my component. And let's just make sure this works. Right? The whole goal was I wanted to make sure that this will resize if I change this value. So I'll go ahead and change this to 785. Rebuild. And you can see the holes will still line up over here. And it doesn't move the pump guard over. Right? It doesn't shift it to the left because I've added a larger value. Okay? So you can see here, they still stay in place. So now, if I pop back over to my assembly, what I want to do is I want to take a look at virtual components. So all of that was a virtual component. It's saved internally inside the assembly, so there's no separate part or subassembly file. Okay, there is an option for you to have it saved externally, always, which is a real part, or work with virtual components, right? And you can always save out the external file later. So for now, what I want to, I can decide, you know what, I'm going to use this somewhere else in another assembly, right, this pump card. And right now it's saved internally inside the assembly. And if I locate that pump card where it is on my feature tree, I can go ahead and right click and then say Save Part and External File. If I specify the path, I can specify exactly where I want to place this. I can, for example, save it on my desktop, press OK, Press OK. And notice once I do that, over here on the left-hand side, the brackets disappear. Another giveaway is if I right-click and look for that rename part, I'm not able to rename it because it's now a separate file. It's now an external file, a real component. Okay, I can then do a drawing of this. You wouldn't be able to do a drawing of a virtual component. Okay. So with that said, say for example you don't want to even have to deal with virtual components, right? They may maybe get messy, or they might cause some confusion between your coworkers or the people that you're sending these files to. You go to your options, and on the left-hand side, if you go to assemblies, there's a third option that says Save New Components to External Files. If you go ahead and click on this and press OK, go ahead and zoom out. If I go back to New Part, that's the same way, right? Now I have that checkbox on which says Save New Components to External Files. Notice how it automatically has me save it now, right? So I can say pump guard 2, for instance. And what I'll do is it'll take me back here. And on the left-hand side, you can see how there's no brackets, not indicating that's a virtual component. Okay. So we had a question that says, what flags it as a virtual component in the feature manager, right? The biggest giveaway that you can see without having to right-click anywhere is there's a bracket. So you can see over here, we don't have a bracket because I had saved that externally already. But if I kind of go through that same process, or I uncheck this, go out, and create a new one. So this one here is a real component. It's saved externally already. If I go to New Part, and then just select the face, same one as I did before, you'll notice on the left-hand side, it says brackets, and there's also a caret up to show you which assembly it's a part of. Okay, the biggest giveaway would be the brackets. Besides that, there's really no different icon or anything like that. If you wanted to right-click, you'll only see this rename part and save part in a virtual component. You won't see that if, for instance, if I right-click on my real one, you'll see Make Virtual, which will make it allow it to be virtual. Okay, so it'll be the brackets, and if you right-click, you'll see that. So another question is, there's no way to create a drawing of a virtual component? That's correct. So if you wanted to do a drawing of just this pump guard, you would have to make sure you save it externally. Now, if you do a assembly drawing of the entire assembly, right, the pump guard will still be in there, and it'll also populate inside the bill of materials as well. But if you want to do it of just that pump guard or just that virtual component, you'll have to make sure you save it out externally. Okay. Good questions. Okay. Hopefully that answered your questions. So I'll go ahead and now exit out my sketch out of component mode. Awesome. And then now I'll pop back over to my PowerPoint. Okay. So now we also have assembly features, right? And think of these as material removal features that are created inside the assembly. They're typically used to represent post-assembly operations, right? Things that are done after the components are assembled. And there's also a propagate feature to parts, which we'll talk about as well, right? But generally, when you're thinking about an assembly feature, you only want it in the assembly, right? So that's what SOLIDWORKS created. They created assembly features that only affect the assembly. So for instance, if I pop back over to my bolter, what I'm going to do is I'm going to identify a subassembly that I'm going to be working with, and I'm going to locate it. I'm going to go ahead and click on my F key. There's a custom views that I've already set up, right? Also very useful if you're using large assemblies or you don't want to have to constantly navigate around your model. Click the spacebar. I've had these preset standard views already. So for instance, I want to look at this component right here. If I right-click on it and go to select subassembly, this is an easy way, instead of having to navigate on your feature tree on the left-hand side, it's an easy way to navigate exactly where, each component is. Also a little shortcut, let me go ahead and go back. On the left-hand side, you can see here how I have my feature manager expanded out, right? An easy way to collapse this, if you want to be able to just see a quick top-level view, is you click in here and go to Shift-C. What that'll do is collapse your feature manager for you, okay? So that's Shift-C. I mentioned before that if I wanted to find the subassembly that this component is a part of, I can right-click, go to Select Subassembly, and you'll get this menu if there's multiple subassemblies this is a part of. I prefer right-clicking because what that'll allow you to do is once you find which subassembly you're looking for, you can go ahead and open it up. So for instance, this 0301 is what I'm looking for. I can easily just go here, right-click, and go to Open Assembly. So now this is kind of what I'm going to be working with for my external references and my assembly features. I can see here that I have some holes that are lined up correctly, which is great. But if I modify this value, what I'm going to find is that the holes don't move, right? And in that case, I want this to be driving the location of these holes, as well as the size. So one of the things I can do is I can first just go ahead and delete these holes so I don't have them there already. There's no confusion. And what I can do now is create an assembly feature. Okay, so you notice I'm in the Assembly tab, the Command Manager. I'm going to go to Assembly Features and do a extruded cut. I can select this face, and then afterwards I'll do the same process as I did before, where I'm selecting the entity. I can select it beforehand. If you don't worry, you can just go to Convert and then select it afterwards. Here you don't have to hold down Control. Right-click to press OK. What it's done is propagated those entities onto the plane that I'm on. And I'll go ahead and do a extruded cut. Also, this has happened to me before. It has happened to you guys. Not specific to assemblies, but if your Command Manager ever undocks, all you have to do is just left-click twice, double-click to bring it back. Or another one is if you left-click, notice there are 3 squares that pop up. That one up top here, this one over here, as well as the one over right. This allows you, but in this case, what I want to do is just dock or let go. Okay, so one of 2 ways: you can double click on it to dock it back to where it was, or just left click and drag it back up. Now, I'll go ahead and do my extruded cut. We'll do through all and press OK. So this is an assembly cut. Okay, once again, I want to make sure that that worked. So I'll double click, make that change to 120, rebuild that, and you can see the holes do move. Now, if I open up this part, do you think the feature will be there? Okay. In this case, if you remember this is an assembly feature, it doesn't propagate. Okay. So it's specific only in the assembly. It's not in the part. But then, for one, I do need it in that part. Maybe it is a pre-assembly operation. There is a checkbox that allows you to propagate that feature to a part. So say we run into that scenario. Say, you know what, I want this cut to propagate down. So you can edit the feature, scroll down. There's a propagate feature to parts. If you click on this, you can then identify what part wants to be affected, in this case, this one. Now, if I go ahead and right-click and open up that same part, you can see those holes now carry over. Okay, so you have an assembly level feature that does extruded cut. If you don't propagate, it will only be in the assembly. But if you decide later on, I do need it inside the part as well, you can go ahead and propagate the feature to the part. Okay. Now, I've had a question where people have said, okay, you know what happens if you modify this one? How does it propagate to the assembly? Right? Because you can see it listed here. So once I expand this out, this is what we call the derived sketch. And it's a derived sketch, meaning it's driven by another sketch. Okay, this is a sketch that's been derived from something else. In that case, because the sketch was done in the assembly, that's where the original is. So if I wanted to even, if I right-click, you can see there's no Edit Sketch button. There's a Suppress. I can hide it, but I'm not able to edit it. So for instance, if I want to add in another hole in here by myself, I wouldn't be able to do that, okay? Because assembly level as an assembly feature. So what happens if you run into a scenario where you want it both in the assembly as well in the part, and you want to be able to modify it at the part level? Okay, that's where you're going to have to do it in context. So if I pop back over here, what I'm going to do is delete that assembly feature as well as that sketch. And then now I'm going to make a in context edit. Okay, so I'm going to go and edit this part. It's almost the exact same thing as we've done before, where it has an external reference, how we did it with the pump card, how I was referencing other things, right? But you can also do this for real components too. It's not specific to just virtual. So here it's a real one. I'm going to right click and go to edit part. Notice how, once again, the command manager now changes. Up top, I see features, surfaces, sheet metal, weldments. Those will only be available if you're inside of a part or editing a part. The advantages here is I can reference something else. So if I go here to sketch, and then next, scroll, go to convert entities, and select those same exact edges, and do an extruded cut. Make sure it goes through all. Then press OK. Go add edit component mode now, right? And I modify that to change to 300. Make sure it works. And if I pop back over my part now, you can see it's still there, but the difference now is if I can right click, I can edit it. Before I was only able to suppress it and unsuppress it. So if I want to add another hole in here at the part level, I can, because I edited the part. Okay. So that's the difference. Level feature that's only in the assembly. You have an assembly level feature that also propagates down to the part, and then you also have a in context feature that has an external reference to the assembly. Okay, so you can see those three different scenarios. Now you'll notice that I have this dash and this greater than sign. So if you've seen that before, what it means is it has an external reference. So basically this means that this was done in context. Okay, that means that it has another assembly or another part. And the second one is if you ever have something that's out of context. Usually you'll get this when you have an assembly and the assembly isn't open, or the part it's referencing isn't open. It doesn't know, hey, has this been updated before? Has it changed? Right? So that's why there's a question mark by it. There's also an ability to lock your reference. This will allow you to not add any more. It's kind of like suppressing and unsuppressing your reference. Say, for example, you want to test something out, but you don't want to remove the reference. You're able to lock it. And then also there's a broken reference where you say, you know what, I'm going to use this in another assembly. I don't want to automatically update it anymore. You can just quickly break it. So let's do the last two. So I go over here to my assembly. Easiest way to see what has an external reference is to go to the very top level, right click and go to list external references. Click on it. And you can see here a list what has external references. If I click on this, I can go ahead and block it. I also mentioned break. So the thing with break is you're not able to reverse the process. Once it's broken, it's broken. Okay. So here we have lock. You can see here it says all external references of the selected model will be locked. You will not be able to add any new external references until you unlock it. So if you press OK, I mentioned this is kind of like it's a suppress and unsuppress, right? The reference is still there. But if I wanted to, for instance, if I wanted to edit this part, you can see over here, the component you're editing is being locked. You can edit it, but can't create external ones, new ones, right? If you wish to add external reference, you have to unlock it first. So that's the first part of locked. And also, if I wanted to modify this, because it's locked, you're going to see that the hole doesn't move. Okay? So it's pretty much allowing you to, if you want to do some investigation somewhere else, but you didn't want it to update, you can almost suppress and unsuppress that reference by locking it. To reverse that, it's pretty simple. All you have to do is go to the same, right-click, list external references, select it, and you'll notice as I click unlock, if you look over here on the right-hand side, you can look at the holes. Once I click unlock, you'll see the holes will move down to where they should be. Okay? And of course, there's break. And break, once again, will display an X by the external reference, and it will not update. So that brings up another question of, okay, if you don't want to break it, but you want to remove that reference, how do you do that? So the way I like to show it is, if I want to open up this part, it's really simple, right? I just have this feature, once again, indicating that has an in-context external reference. If I want to remove it, right, I have to figure out, okay, what's linking it back to the assembly? So if it's the feature or the sketch, and in this case, it's the sketch. So I have to right-click and go to Edit Sketch. Okay. So what exactly in this sketch is linking back to the assembly or to another part? And you can see here, it's the references, right? You can see everything's fully defined. There's no dimensions besides these relations here. Now, if you have a lot of relations and you can't easily choose exactly, know which one is which one has an external reference, you can go relations, click on it. Inside it gives you a list view of exactly all the relations that's inside the sketch, what's dangling, what's overdefined, what's in context, and also a dash and greater than sign indicating the external reference. And then you can subsequently delete the ones that you don't need. In this case, there's only really 2 in here. Okay? Press OK. And then you'll now see we have some underdefined geometry. It no longer has that reference to the. If I were to exit out my sketch, notice what happens with the dash and the greater than sign. You'll see I no longer have it. But another thing I do have, though, is this minus sign. Okay? Most likely you guys know what this is. This is indicating that this is an underdefined sketch. So there's geometry in there that I have not locked down as degrees of freedom. So if I wanted to edit the sketch, I can easily fully define this. I can select all of it and just fix it in place. Or I can add in dimensions of my own. And there's also a fully defined sketch under Display Delete Relations. If you click on Fully Defined Sketch, what this will allow you to do is fully define all the entities in the sketch or selected ones. And then if you choose a reference, for instance, like an origin, what this will do is use that as a reference point. Press OK. And relations. Okay. And then if these are all editable, they're not any different from regular dimensions. If you decide, you know what, I need this to be 108, you can go ahead and change it here. Same thing applies. If you exit out of the sketch, there is still no external reference, and it's now fully defined. Okay. So what we do is we take the process of, okay, we've done an in-context reference, and then now it's a matter of, okay, I want to, afterwards, I do want to use it somewhere else in another assembly, but I don't want it to update, right? So you're in that situation where you created it, first of all, in context, but then you want to use it elsewhere. You can go ahead and dive into your sketch, take a look at what references, what's tying it back to the assembly, remove those, and fully define the rest of it. So with that said, pop back over to my assembly. Managing external references is critical at that point, right? And it can be very difficult. So really your options are to avoid them, just don't do them, right? Do bottom up. Or better yet, have a plan for them, right? Easier than just omitting that process, you actually have a plan for it, right? Easier said than done, but it's one of those where the more users you have, just making sure everyone's on the same page. Any questions? Hopefully you guys are just kind of popping questions as we're going through the process. Okay, and if you do, just go ahead and write them out, and then I'll answer them as we go along. And the last thing I want to cover today is master modeling technique, right? And really simple, it's using a part to drive an assembly, one part. That one part is our master model. So we can take a look at the flow. It goes from master part model. use push and pull design features to create our subcomponents, and then we'll go ahead and assemble that into an assembly. Okay? So we have one master model, one master part that controls everything. If I make a change to the master model, it'll make a change to the individual parts and also the assembly as well. Okay? So very effective for curvy shapes. So let's take a look. We have this control knob that I want to take a look at. Very simple, has two solid bodies, one left side, one right side. One has hooks, one has grooves. Okay? And what I want to do is put this into an actual assembly. So I want to have two components, and I also want them to mate up together. And if I make any changes, I can do it just at the master model level, which is this control knob. It'll propagate down to my subcomponents as well as my assembly. So now, if I go ahead and go to New, what I'm going to do is demonstrate the pull operation. Okay, so we'll do pull, then push. So pull is you have basically your new part, and what you're going to do is pull that master model in. So we're going to go to Insert and go to Part. You're pulling this model in. So what we're going to do is find that control knob, go to solid bodies over here because it is a solid body, and then press OK. Any other information you want to bring in from the model, you can. Go ahead and press OK. And then component, right, our master model that's inside of our subcomponent. And I'm going to go ahead and delete one body. I'll save that file, save as. I'm going to call this my pull left. And just edit that feature and switch it to the right side. So that'll be file, save as, pull right. So what I have now is a pull left component that I brought those in, and then now I want to make an assembly from the part. First, I'm going to bring in the pull right and just go ahead and press OK. Insert my component, browse, and I'm going to bring in that pull left. And press OK. You'll notice how it comes in so easily, right? How did it already know what it looks like? How did it, made up the two together very well? That's because of the assembly. That's because of the master model, right? They share the same origin, so it looks almost exactly like the master model. The advantage is, if I make any change to the master model, propagate down to the subcomponents and then the assembly as well. So that's one thing, right? That's the pull command, where you're starting in the subcomponents and then you're pulling it in master model into your subcomponents. Now, we have the push method. Or if you go to your window, I'm going to go to my control knob. I'm going to go ahead and close down my pull right. I'm going to save this. This is my pull assembly. And now what I do is a push method. So the push is going to be initiated from the master model. So I'm pushing out my subcomponents. So I'm going to go to Insert, Features, and then do a Save Bodies. So on the left-hand side, I'm going to go ahead and indicate exactly which of my components is which. This one's going to be my pull left, my push left, because I'm pushing from the master model. And then now I want to make sure this is push right. I'm going to make sure I do not check on consume cut body. Let's turn that off. And while I'm here, I can also create the assembly as well. So I'll go ahead and just call this push assembly. Press OK. And what it's doing is creating the subcomponents and then assembling together in my assembly. So what I have now, go ahead and close my push right. And then we'll take a look at my push assembly. Which is here, right? Looks very similar. Go ahead and push left. So I have my push and my pull. Looks very identical, right? The difference is, though, when I go to the master model, think of this control knob as my master model. I'm going to go ahead and make a change to this right plane. Add in a little cut, do an extruded cut, and make sure I go through wall in both directions. So what I've done is made it, right? The whole concept is if I propagate down to my subcomponents, my assembly as well. That's why I did two of them, right? Two operations, one pull, one push. You can do either or. The difference is if I go to my pull and click yes, you're going to see that that hole will populate down, right? As it should. But if I go to my window and go to my push, do you think the hole will propagate down, right? So right now, if you're guessing, you have about 7 seconds. What do you think? In this case, you're going to find that it doesn't, right? So the next question is why? What's the difference? So you go to my window, go back to my master control, my control knob, you're going to see that the save bodies. So think of the save bodies that was initiated from the push command, right? And what that's done is essentially created a timestamp, meaning that anything that happens before in this model, I'm going to propagate down to my subcomponents, but nothing after the fact. So it's feature history based, like all of SOLIDWORKS is, right? So anything after the save bodies is not going to carry over to my save bodies, which was the push, right? The second one I've done. That's why the second assembly didn't have the hole. So the pull will always link back to the original. So anything changes you make to it will always maintain that. But you can see here with my save bodies, anything before will always carry over, but nothing afterwards. But a simple fix for this, if you did the push command and you wanted that cut to be in there, you can simply just left click and drag up before the save bodies. And if I window over back to my push and click yes, you can see it'll populate there. Okay. So once again, push and pull, you can see the differences, right? But master modeling is a very, very powerful technique. So how to avoid the headaches that might come with either in context and master modeling as well? What we find is if you're doing master modeling, it's generally for smaller projects, and it's also for fewer users, right? One of the engineers I talked to, he's the only one that does the master modeling, okay? So, I mean, with that, you always know that you're going to be on the same page as yourself, as well as a few other users, right? But if you're getting to maybe a size that's a couple hundred engineers or so that are working on the same project, it's more difficult making sure everyone's on the same page. So questions you have to ask yourself is, does top-down design make sense for you? Once again, it's best suited for one-of-a-kind custom components specific to that particular assembly, smaller projects and fewer users. So at the end of the day, it's to your benefit to have a plan and just to make sure everyone's on that same page, okay? So really that's going to cover the first part of what I want to talk to today. Unfortunately, there's no prizes, but you know, I wanted to make sure that we covered over top-down design, talked about assembly features, as well as master modeling techniques, right? Understanding the importance of it, that you definitely have that capability is very powerful, but if you're going to be using it in your design process, making sure everyone's on the same page and having a plan for it, right? So I had a request for mouse gestures, right? So at this point, go ahead and just fill in questions if you guys have them. I'll go ahead and answer them as we go along. But then someone had asked for mouse gestures. So mouse gestures are, you go ahead and under your options, pull the drop-down menu, and what you want to do is go to Customize. And you're going to go to Mouse Gestures. And over here, you're going to enable them. Make sure it's enabled first. If you want to turn it off, you can disable it. You have the choice between 4 and 8 gestures. And over here is where you assign it. It's going to be specific for part, assembly, drawing, and sketch. Okay? So notice, for instance, if I'm in a sketch and I do a lot of circles, right? Instead of having to find circle on here, I can just type it in. And you can see here I already have circle in there. So that means if I go to my right click and go to my right, I'm going to have the ability to do a circle. Okay? And also you can see, if I remember I did dimension, if I'm inside of a sketch and I right click and go up, allow me to do a smart dimension. Okay? So this is where you'll customize it. You'll set it to what you want it to be. Maybe you do it on dimensions relations, then right-click, go to the left. This will activate it. Okay? So this is where you'll customize it. I had a question about when you highlight a feature, you have arrows showing parent-child relationships. How do I turn that on, right? And also the same question by somebody else, that the parent-child arrows, right? So that is a new feature inside of SOLIDWORKS 2015. And if you guys have it, what you'll do is you'll right-click up top here to your part or your assembly, and there's a dynamic reference visualization, right? If I turn that off, I won't have that. But if I right-click here and turn that on, it'll allow me to dynamically figure out, okay, what has a reference to what. For example, that feature has a reference to the origin as well as that extrude, because that's what it was cut on. Okay, so that's going to be in your 2015. That's where, if you have it, that's how you would turn it on. But if you don't have it, unfortunately, if it's like 2014 or a previous version, it'll be available for 2015 when you want to upgrade. I have a question. Sometimes when I open an assembly, I get this lightweight mode. What's the purpose and advantage, and how can I get out of this mode? Okay, so that's great. We actually do cover that tomorrow, but just a really quick reference. If something's loading up lightweight, then most likely you have things, for instance, you have this one checked on. If it's a smaller assembly, then it's most likely because you have automatically load components lightweight on. Okay, so what lightweight does is it removes pretty much a lot of the features. So if you expand out your component, you're not going to see your features in there. You'll still be able to mate to it, add in additional mates in regards to the assembly, but you won't be able to edit it. You'll have to fully resolve it. So uncheck this if you're less than a certain number of components. Under assemblies, if you have a large assembly mode on, if your assembly goes above this number, then large assembly mode will activate, as well as lightweight will activate as well. Okay, so if you don't want that to happen, just uncheck this as well. Another mode, if you're inside the assembly already and it's loading up large assembly mode. So I pop back over here. If you go to Tools, while you're inside already, how to toggle it off. As you go all the way to the bottom, there's a large assembly mode. If you uncheck that, then you'll have all of them load lightweight resolve, and you'll right-click here, and you'll go ahead and just make sure there's the opposite where it goes lightweight to resolved. So just make sure because I don't have anything lightweight right now, you'll see the reverse where you can set everything to resolve. You don't have to worry about lightweight. Can you explain assembly visualization and assembly expert? That's a good question. We actually do cover that tomorrow, right? So I don't want to kind of go into detail because we do cover it tomorrow, but just really quickly under evaluate, assembly expert, well, it's going to give you a long list of data, which we'll cover tomorrow, right? Things like number of components, mates, diagnostic tools, how many components are in here. And assembly visualization, you can use that to also narrow down what has the most mass, what has the most rebuild time inside of your assembly, and then pick and choose for large assembly performance. Okay, so we'll cover that tomorrow. All right, guys, with that said, I'll go ahead and if you guys have any questions, I'll go ahead and be on tomorrow, same time, continuing forward. And thanks for tuning in. Bye, guys.